Let f of x equal the natural log of 1 plus x to the third. The Maclaurin series for the natural log of 1 plus x is, and they give you that, the series for that function, and the general term. Use the series to write the first four non-zero terms in the general term of the Maclaurin series for f. So we have to plug x plus 3 in for x, so it's a replacement. So we're going to replace all of these x's with x to the third. So I have x to the third, x to the sixth, x to the ninth, x to the 12th, and that is down here. Now they want the general term as well. This alternates, so we have negative 1 to the n, x to the 3n, these are multiples of 3, and then underneath we have 1, 2, 3, 4, so over n. And then I wrote it as sigma notation. B, the radius of convergence of the Maclaurin series for f is 1. Determine the interval of convergence. Show the work that leads to your answer. Well, if the radius of convergence of a Maclaurin series that's centered at 0, if it's 1, we can write that right there. We can write negative 1 less than x less than 1. Now we have to test the endpoints. So we test negative 1, and we're plugging negative 1 in for this x right here. So when we add 3n plus n, we get 4n. Well, that's going to always be even. So that's the same as just 1 over n. This diverges by the harmonic series. So we've tested negative 1. When we test 1, we're going to plug 1 in for this x up here. And we get, well, that's just going to be 1. So we get negative 1 to the n over n. This converges by the alternating harmonic series. So did I ever write the actual interval of convergence? Looks like I didn't. Interval of convergence is equal to, let's see, it diverges at negative 1 and converges at 1. Write the first four non-zero terms of the Maclaurin series for f prime of t squared. If g of x is equal to the integral from 0 to x of f prime of t squared dt, use the first two non-zero terms of the Maclaurin series for g to approximate g of 1. So write the first four non-zero terms of the Maclaurin series for f prime of t squared. Well, let's get f prime. That's there. So f prime is the derivative of this right here. So 3x squared, 3x to the 5th, 3x to the 8th, 3x to the 11th. Interesting. Look, all of those are 3's. So then we're going to plug in t squared for all the x's. That becomes t to the 4th, t to the 10th, t to the 16th, t to the 22nd. But then to find g, we're going to take the antiderivative of what we just found. So the antiderivative here is 3/5 t to the 5th, 3/11 t to the 11th, and so on. But then it wants us to approximate g of 1 using only the first two terms. So only using these two terms right here. So 3/5 minus 3/11, 33/55 minus 15/55 is 18/55. The Maclaurin series for g evaluated x equals 1 is a convergent alternating series with individual terms that decrease in absolute value to 0. Show that your approximation in part C must differ from g of 1 by less than 1/5. So they're talking about error. So we need to just evaluate the next term. So the error in an 11th degree polynomial evaluated at 1 is less than or equal to the value of the next term, 3/17. So 3/17 is less than 1/5. Here's the rubric if you want to take a look at what gets you all the points. Let f of x equal sine of x squared plus cosine of x. The graph of y equals the fifth derivative is shown above. So this is the absolute value of the fifth derivative. Write the first four non-zero terms of the Taylor series for sine of x about x equals 0, and write the first four non-zero terms of the Taylor series for sine of x squared about x equals 0. So sine of x is an odd function. There's the first four terms. And then we're plugging in x squared for x. All right, the next is b. B, write the first four non-zero terms of the Taylor series for cosine of x about x equals 0. Use this series and the series for sine of x squared found in part A to write the first 4 non-zero terms of the Taylor series for f about x equals 0. And f is sine of x squared plus cosine. Well, cosine is an even function, so there's cosine. And then we're going to add those two together. We're going to add sine of x squared and cosine together. So we have 1, and then x squared minus 1/2 x squared is 1/2 x squared. Then we'll have x to the 4th. There's that one. And then the 2x to the 6th, which is 1/6 minus 1 over 720. So we have 1 plus x squared over 2 plus x squared to the 4th over 4 factorial minus, it ends up being 121x to the 6th over 720. Letter C, find the value of the 6th derivative of f at 0. So letter C, the 6th derivative of 0 is equal to, well, there it is right there. It's negative 121, and it's over 720. It's over 6 factorial. So the 6th derivative is negative 121. Let p sub 4x be the 4th degree Taylor polynomial for f about x equals 0. Using information from the graph of the 5th derivative shown above, show that the error is less than 1 over 3,000. So the remainder, or the error when we plug in 1/4, is we need the 5th degree, which if we go up here, we have 1/4 plugged in. Here's all the way to 1. This must be 1/4. So right here, we could say it's 38 or 37. But what if we just raised it up, widened the margin, and said that the actual value is 40? So we're going to use 40 over 5 factorial. So there's the derivative over 5 factorial. And then that's 1 over 4 to the 5th. So that's actually the x value. So the x is sitting right here, x to the 5th. When you plug that 1/4 in, you're going to get 4 to the 5th. So when you do a little math on this, we end up with, 2 times, we start canceling stuff out. So you can cancel one of the 4s, make that a 10. This is 2, 3, 4, 5. Start canceling stuff out. And you find out the value is 1 over 3,072, which is less than 1 over 3,000. And here's the rubric for this problem. Write an expression for the nth term a sub n. So we have the summation n equals 1 to infinity of a sub n is 1/5, 1/6, 1/7, 1/8. That's 1 over n plus 4. Does the series converge or diverge? If the series converges, find what the series converges to. So this, the r in this one, this is geometric. The r is 3, but that's greater than 1. This diverges by geometric series. This one is also geometric, but the r is 1/4. That's less than 1. So this converges by geometric series, and it converges to 1/3. Express a number as a ratio of 2 integers. So we can break this up into 0.21 plus 0.0021 plus 0.000021, and so on. Well, a sub 1 is 0.21. R is 0.01. That's what we're multiplying by to get the next term. So here we have a sub 1 over 1 minus r, and that's going to be 0.99. And then if you multiply the top and bottom by 100, you get 21 over 99. Find the 3rd degree Taylor polynomial for f of x equals 1 over x squared centered at x equals 2. Well, we got to go back to just taking derivatives on this one. So we start out with x to the negative 2, and when we plug 2 in, that's 1/4. So we have 2 to the 3rd in the denominator, 2 to the 4th in the denominator, 2 to the 5th in the denominator. So those are the derivatives, and then of course when we're doing it the long way with derivatives, we need the factorials. Find the first 4 non-zero terms of the Maclaurin expansion for f of x equals x squared cosine of 2x. We'll replace first, and then we'll multiply by x squared. So here's cosine. Cosine is an even function, so we have all the even powers. Replace all of the x's with 2x. So don't forget to square the 2. Don't forget to take the 2 to the 4th and 2 to the 6th. So then we distribute x squared through.